And this evening, we kind of went over this problem in a little bit of detail. And one of the things I realized after we had finished this evening was that I kind of took the wrong approach to this problem. And so, first of all, I'd like to apologize for that. And second of all, I'd let you know that I'd like to show you the correct way to approach this problem. So, the first thing we have to understand is that we were given a boat and we were told that its initial velocity in this direction, the easterly direction, so east, was 5 meters per second. We were also told that this boat was on a river that had a current flowing north at 2.5 meters per second. And one of the things that you had to do for this particular problem is you had to come up with a resultant velocity vector. Okay, so we are going to take the tail to tip approach, and we are going to draw our one velocity vector of 5. And I'm going to just hold off on the units for a little bit. And we are going to do our other one here of 2.5. And we are looking for not only this resultant, which I will call capital R, okay, and that's actually not a very good capital R. So let me go ahead and do that. Capital R. And here's where one of the steps that I forgot this evening, you need to find this angle. Hence the reason that this problem is put on your sine, cosine, tangent problem sheet. Okay? So, you need to find that angle. Now, you guys tonight did a great job. You found R, and after applying your significant figures, we found that R was 6 meters per second. But we need to know at what angle. Okay? We know that it's going to be in the northeast direction, but that's not good enough for this problem. In order to solve the rest of the problem, especially part C, which we had some questions about, especially to solve part C, you need to know the angle. So the question is, what can you use to solve the angle? Well, I want to draw your attention to this triangle here. Okay? The angle here, okay, can be found using either sine, cosine, or tangent. Now, in the original problem, they give you this 2.5, which is opposite the angle, and this 5, which is adjacent the angle. So in theory, we could use the inverse tangent, because tangent of any angle, in this case theta, is the ratio of the opposite side to the adjacent side. The 2.5 is the opposite, and the 5 is the adjacent. And so we can use this information to our advantage. So we are going to go ahead and do this kind of math. In order to find just the angle, you have to take the inverse tangent of the ratio. So I'm going to rewrite this. And basically we're going to say the angle is equal to the inverse tangent. Okay, so inverse tangent, arctan, there's a lot of words, but basically the inverse tangent of the opposite over the adjacent. Okay. Now, and that's just kind of the way I write it. So the inverse tangent. Now, we would say then that the angle is equal to the inverse tangent of 2.5 over 5. And this ends up giving us 26.6 degrees. Now, one of the things you have to be careful of when you're using your calculator is that it's in degrees. One of the things, sometimes the calculators are set to be in automatically as radians, and we don't want that for this particular problem. So 26.6 degrees. So our resultant is 6 meters per second at 26.6 degrees. And we can write that even in here as 26.6 degrees. And that is something that's going to become very important for us. Now, this was part of A, and it was something that needed to be included. Part B is unaffected by this angle, but part C requires this angle to be completed. Okay, so let's look at part C for a moment. Part C, they give us some other information. Okay, let me go ahead and go to a new page. All right, in part C, they want to know how far the boat is going to travel downshore. Now, as in all problems, I really like to draw pictures. So I'm going to draw another picture. So let's say this is the starting point of the boat. This is the opposite shore. Okay, so I'm going to go SP for starting point. I'm going to go to, this is going to be the shore. But the boat is going to drift. And it's going, as it travels from left to right on my screen, it's going to drift downstream like so, okay, following this dotted sort of dashed line until it hits this point where the star is. Okay, so they want to know how far downstream is the boat going to travel, and that means they're looking for this distance right here. Okay, this is what we need to know. How far does the boat travel down the shore? Okay, question mark. All right, so we're going to figure it out. They tell us that from shore to shore, it's 80 meters. They also, and now we know based on our previous problem that the angle is 26.6 degrees. Okay, so we can use this information to our advantage. We need to find, if this was a right triangle, which it is, we need to find x right here, which happens to be opposite the angle theta. So what do I have? Well, I have the following. I have an adjacent, okay? I need to find the opposite, and I have an angle, okay? So I have opposite, adjacent, and an angle. So I'm going to revert back to tangent again. All right, but this time I know the angle. So the tangent of an angle is equal to its opposite, x, over its adjacent, 80. Now, I want to go ahead and replace that theta with the 26.6. So the tangent, 26.6, is going to equal this. To get that x by itself, I'm going to need to multiply both sides by 80. And what I'm going to see happen is the 80s on the right are going to cancel out. And so I'm literally left with 80 times the tangent of 26.6 degrees equals x. Now, the tangent of 26.6 is actually 1/2. So 80 times 1/2 equals 40. So the distance the boat travels down the shore is going to be 40 meters. Okay, now that is much different than the answer that I originally gave. And so I wanted to make sure that I clarified that before you guys went to class tomorrow. So thank you for watching. And if you have any more questions about this problem or similar problems, don't hesitate to send me a message. All right, thank you, and I hope you guys have a great rest of the week.